First, to understand inclined plane, we need to know what is static friction. Friction is a force that keeps an object at rest. If a small amount of force is applied to an object, the static friction has an equal magnitude in the opposite direction. If the force is increased at some point, the value of the maximum static friction will be reached and the object will move. Mu is used to represent the coefficient of static friction. The formula for friction loss is equal to normal force times the coefficient of static friction. Then we rearrange the formula and we get that the friction loss over the normal force is equal to static friction. After that, we get the component x in our inclined plane, and we get that force in x minus friction loss is equal to 0. Next, we rearrange and we get that they are equal. With that knowledge, we get that force in x over normal force is equal to static friction. Then, we need to disclose the forces using trigonometry. And after that, we get that force in x is equal to mass times gravity times sine of the angle, and the normal force is equal to mass times gravity times the cosine of the angle. Next, if we divide the components of the force in x over the components in normal force, we get that sine over cosine is equal to the tangent, and we eliminate the mass and the acceleration, that is gravity. And finally, it only remains the tangent of the angle, and that is the static friction.
The first formula that we're going to use is the friction one, that is the coefficient of static friction times the n that acts as a normal force. And in this, it acts as the same as the coefficient of static friction times m, that is the mass of the object, times g, that is the acceleration of gravity.
The materials that you will need for this experiment are a plane or a board of wood with at least 0.5 centimeters of thickness, 50 centimeters long, and 20 centimeters in wide, an empty and light container of any shape, a set of three masses of 0.2 kilograms, 0.4 a set of three masses of 0.2 kilograms, 0.4 kilograms, and 0.6 kilograms, and a protractor to measure the angles.
Now here's the procedure.
1. Place the plane at ground level and have the extreme A leveled differently than side B. Make sure that extreme A remains fixed. The only extreme that can rotate is extreme B. Attach the design surface to the base of the container. You can stick it with glue. Number 3. Place the first mass 0.2 kilograms inside the container and put the container at the center of extreme B. Very slowly raise the level of the extreme B so the plane passes through the different angles. Number 5. At some point you will notice the container starts to slide downwards. Stop raising the plane at that point and record the angle with the protractor for which this happens. We will call this the critical angle. Repeat this process 9 times more and record the critical angle for each repetition. Always make sure to raise the plane very slowly and continuously. Then proceed to do all the calculations indicated in the formulas. Try the same experiment for the other two masses, 0.4 kilograms and 0.6 kilograms, to confirm that it's the same in all of them. This confirms that it is independent of the masses used and only depends on the two surfaces being used for this experiment.
As a conclusion, we can say that friction depends on the weight of the object, the amount of force applied on the surface by the object, and also on the surface in which the object is moved. We could also notice that the applied force that tries to slide the object is always equal to the force of friction acting on the object. Our results show that the coefficients of friction, time, and angle can vary.